On the primordial shores, 420 million years ago, a group of arthropods made an evolutionary decision that defied their ancestral legacy. They abandoned the ocean to colonize land. These pioneers, sea scorpions called eurypterids, became Earth's first terrestrial animals despite the harsh conditions, searing temperatures, oxygen levels 30% lower than today, and deadly ultraviolet radiation. Their success came from two revolutionary adaptations: specialized book lungs that use muscular contractions to force oxygen into their bloodstream, a primitive version of our own respiratory system, and thick armored exoskeletons that shielded them from the hostile environment. Yet the barren landscape offered little sustenance until an unexpected opportunity emerged. Our ancient ancestors, the jawless cephalaspis fish, had completed their own remarkable migration from ocean to freshwater lakes. When their breeding grounds became isolated by newly formed landmasses, these flexible vertebrates did the unthinkable. They began flopping onto shore to spawn. Their success was short-lived as the sea scorpions, detecting the commotion, swarmed the area like predators at an all-you-can-eat buffet. What had been challenging underwater hunts now became effortless feasts on land. Most sea scorpions gorged themselves, except for one unfortunate individual caught mid-molt. Unlike soft-bodied creatures, arthropods must periodically shed their rigid exoskeletons to grow. This 36-hour vulnerable period proved fatal. By the time it completed its molting process, its kin had devoured every last cephalaspis, leaving the latecomer with nothing but empty shores. At this pivotal moment, our evolutionary ancestors, the cephalaspis, were about to achieve another biological miracle. Over millions of years, their gills gradually transformed into functional jaws equipped with teeth, finally granting them offensive capabilities. Their fins and shoulder structures subsequently developed robust bones and muscles through constant evolutionary arms races with predators. The clear outlines of primitive limbs were now visible. These transitional creatures, now called hynerpeton, had gained the capacity to leave their aquatic cradle. Despite resembling giant salamanders, these 1.5-meter-long amphibians would become Earth's first permanent terrestrial residents for the next 300 million years. While still requiring regular water immersion to maintain their moisture-dependent skin, their sheer size allowed them to prey effortlessly on descendant arthropods that once threatened their ancestors. The land presented a transformed world. Over 5,000 years, primitive plants had evolved into towering trees. With minimal animal competition, vegetation flourished, elevating atmospheric oxygen to 30% compared to today's 21%. This oxygen-rich environment enabled hynerpeton's crucial evolutionary leap. They developed complex lungs functionally identical to modern terrestrial vertebrates, utilizing the same inhalation-exhalation mechanism we still employ. However, aquatic dangers persisted. Ancient sharks remained lethal threats until an even greater predator appeared, the 5-meter-long Hyneria. When a shark chased our amphibious ancestor, the colossal lobe-finned fish intercepted with devastating efficiency,